I begin today by acknowledging the traditional custodians of the land on which we gather today and pay my respects to their elders past and present. I extend that respect to Aboriginals and Torres Strait Islander peoples here today. So, before we start, we have a code of conduct here. Our community is dedicated to providing an inclusive environment for everyone, regardless of gender, gender identify, and expression, age, sexual orientation, disability, physical appearance, body size, race, ethnicity, religious, and yeah. And you can also find a copy of that on our GitHub page. So this is our web handles. So we have LinkedIn and Mastodon. If you want to follow, you can easily find them online. And let's go through the agenda for today. So yeah, as we are going through the introductions right now, then we have a talk coming up at 6:15 by Alan Perkins, who's the founder at Profound Information. Then we'll have a break, then another talk, and then we'll have a marketplace where like recruiters will be having their call-outs for hiring, and then we'll close up at 6:35 and wrap it up by 8. All right, so I'd like to thank our sponsors, Judah Bank, AWS, and Just Digital People. So I'd like to invite Michael from Judah Bank for.
Hi everyone, how's it all going? If you haven't heard of Judo Bank before, we're a SME bank focused on becoming Australia's most trusted bank. So we do loans, home loans, line of credit and term deposits.
Perfect. Thank you so much for the venue and helping us organize the event. Then we have AWS and Just Digital People. So I'd like to welcome James from Just Digital People to share with us.
Cheers, Matt. Hey guys, I hope you've had a good night so far. If you don't know Just Digital People, we are a specialist recruitment agency across technology and digital marketing. Obviously do a lot of Python as well with some of our clients. So if you are looking for a job or if you're looking to hire someone in that space, come and see myself, Natasha or Eva, and we're happy to chat through it. Thanks for Judo Bank for the beautiful venue and obviously the speakers tonight. Looking forward to learning some things. I've already learned something from Kai about Python. Apparently it was named after Monty Python and not a snake. So I'm already learning stuff.
All right, it's awesome to have you guys. So this is the QR code to our Slack channel. Feel free to join and we can chat more about our events on the Slack. Also, we are looking for people to join the community and help us with sponsorship liaison. Then we have speaker and university liaison. And we are always looking for volunteers. So reach out to me or Rinaldi for volunteering at the Meetup. All right, so let's start with our first talk, which is by Alan Perkins. And I'll just give a quick intro. So he's a founder of Profound Information, and he'll be talking about migrating COBOL data to PostgreSQL using Python and Django. So let's welcome him and get started.
Hello everybody, my name is Alan. A little bit quickly about myself. I started out life as a chartered accountant and, but as I like to say to people, I got better. Speaking of Monty Python, there is a joke where they go through all these professions and say, I'm a this and I think that. They get to the accountant, he says, I'm an accountant and therefore too boring to be of any interest. But anyway. The difference between an accountant and a computer, a computer has a personality. I'm not here to talk about accountants. I've been in my career, I've been a CIO. I was a CIO of Altium, which writes software for electronic engineers. Altium was recently acquired for 9.2 billion and it was a lot smaller when I was there, but I was there for about 11 years as CIO. And I have also been CTO of a number of different companies as well. So what I wanted to talk to you tonight about was a project that I personally did. This was a hands-on the keys project that I wrote for a company, which this company had an ERP system. I'll just quickly explain for those who may not know what ERP stands for. It's Enterprise Resource Planning, effectively the back-end systems of any large organisation for inventory control, human resources, financial statement, management, sales pipeline. The entire back-end system is referred to as an ERP system. Their systems were based on a COBOL platform, which they'd been developing internally for about 42 years. And the developers who'd been writing it were literally dying and wanted to retire, but really couldn't because it was, they're all in their mid-70s and they just couldn't get out of there. Now, I happen to know the CIO, and he called me up and he said, look, we're trying to migrate all this data out for a new platform. They had a $53 million budget for a new ERP platform, but they just couldn't get the data out. And can you help us out? So I started to look around the company and talk to a few people, and no one was prepared to help me, and I couldn't for the life of me understand why until I learned that there'd been 7 previous attempts to get this data out and they had all failed. So this was some of the screens that the old system looked like. It was actually a very fast system to run, but it was all very DOS-based, and we did a mock-up. I did a mock-up for them with some web-based front ends and so forth, and then I showed them this video which went around and it became viral within the company, and then the guy who was the business analyst running this system said, you know, they called this system Focus, and they said Focus fights back, and they did this video that took 20 minutes to do the same thing as the 3-minute thing, just due to the fact that it was all DOS-based or text-based. So what I was faced with was data that was highly proprietary, basically stored as a series of raw hex. There were 5,737 files in the current set of files that were processed each day, and over 200,000 files for the last 7 years, all of which had to be processed. It was about a terabyte per year of data, depending on which year you looked at. And every day, because there was no means of telling what had changed in the file, they basically had a rolling 12 months of data in each of the 5,700 files. Each day they would drop off a day and add a day, and so basically each file had to be interrogated to find out what had changed. And so it had to process between 150 million and 1 billion records each day. And the system had to remain processing continuously for about 5 years while they were in the process of working out the migration scripts and so forth to the new ERP platform. So this is what the data looked like. Basically a wall of hex. Some of it was little endian, some of it was big endian, which means it's jumping from left to right to left in the middle, and then back to left to right again. It was quite challenging. This is what that hex effectively would translate. This is a mock-up. This is not the actual what the data is, but it's to give a concept of what it was looking at. And each file could have multiple different record types, so that you ended up with, like the red and the yellow are 2 different record types in the same file. But also you've got the green section here where, with COBOL, every byte mattered, right? Every single byte mattered. And so if you had a null in your data, what did you do? You stuck other data in that space to make up for it. So you had to figure out not only which record type you're looking at, but also what the metadata was in that particular byte space. And that was quite challenging, particularly when some of the record types were not determined by data within that field or value, but in another file. So fairly challenging. So some of the challenges that I did face were, because different programmers had developed different parts of the system over many decades, there was a lot of idiosyncrasies in the data. So for example, there are 8 date formats, and even in the same file. So if a record was written by one subsystem, it would write it in one date format. If it was written by another system, it would write it in another date format, and you had to figure out what the date format was from the data. So you've all heard about Y2K, which particularly related to COBOL systems. Well, it's actually given that one of the date formats was why MMDD? That was the same problem for every decade, so had to figure out that as well. So a fair bit of challenge there. There was duplicate keys, text stored in number fields, corrupt values up the wazoo, and just connections between different files were inconsistent as well. So all of that, just had to use some logic to figure out some of those things. And the encoding was all different as well. So I mentioned encoding, so I don't know if I've got a slide on this, but I might have a mention of this. But one of the things that with this encoding was the idea of overpunch. Who's heard of overpunching as a concept? So you have, okay. So overpunch basically is a means of saving a byte. Instead of having numbers 0 to 9, you have the numbers 0 to 9 and 0 to 9, up to 20 digits, where each digit represents a positive digit or a negative digit. And that way you can save a byte by not having to sign the number, whether it's a positive or a negative number, so things like that. So I developed an application, or a suite of applications, to process all of this data, and it primarily consisted of 3 programs. There was the data processing program, which basically had a number of different processes for each stage. So the first thing it would do was decompress the data files, which came as a series of zip files. And each zip file could have between 1 and 200 files embedded in the zip file. So it had to basically decompress those. And then it would take those files and produce a differential on the file compared to yesterday's version of that file. And then from there, it would then decide what needed to be processed with the database and create a script to execute on the database. The code generator application was run at effectively at metadata check time, if you like, but basically I didn't mention that another challenge through this 5 years is that metadata can change, right? And so the program had to be able to adapt to metadata changes in the COBOL to reflect that in the database and then update the data accordingly, which I'm sure you can all appreciate was not necessarily straightforward. So this code generator program was effectively a program to write the program. So I wrote code in Python to read the COBOL copybooks, which I'll show you an example of. But for those of you who aren't familiar with COBOL, and I'm sure many of you are not, I can guarantee at least one person that is. But COBOL consists of a number of different sections of the code, and one of them is a data definition section, and it's effectively a data dictionary or a schema, if you like, that spells out what the data looks like in terms of where the bytes live. And so this program would read these data definition files and produce data processing classes, subclasses, and there was approximately 900 or so subclasses that were different data processing for different record types throughout those 5,000 files, about 900 different record types in total. And then there was a watchdog application which basically checked to see if new files were coming in. It would just run continuously. It was a multi-threaded Python application that would just check for new files coming in. As soon as it saw new files coming in, this was a pretty dumb process. Dumb in the sense that there was no real smarts associated with it. What it would do, if it saw any files come in, it would fire up instantly 50 virtual machines from a virtual machine scale set. And then those virtual machines would basically take the decompression queues from the entries that this was creating queue entries to say, please decompress these zip files that had arrived. And then it would process them and so forth. But it basically said fire up 50 computers which would instantiate copies of the data processor application on each one of the 50 computers. And logically, this is how it looked. The copybooks were written to the code generator. This is at, not at runtime, but at pseudo runtime, if you like. It was run as a background process. The data files would come in, the data files would get unzipped, differentiated, processed, indexing done, and then housekeeping, and then it would be writing that all to the database. Physically, was involved with virtual machine scale sets, which would go into an inbox manager, which was in that watchdog. And then these 50 different nodes would run and write it to a PostgreSQL database. And it was all done using Azure. Since this is an AWS-sponsored event, I will say that I generally prefer AWS. I'm required to be on Azure, but I don't think I'm giving away any secrets to when I talk of the fact that there is this other cloud provider outside of AWS. No, there are others as well. But basically, we used virtual machine scale sets. The client didn't want to use containers because they didn't. It was pretty early when they just felt a little uncomfortable with containers. Technically, they just didn't feel they had the chops to support them. So this is what a COBOL copybook, which is the data definition file, looked like. And you have picx is saying this is a 1-byte string field. Pic 999 means this is a 3-digit number. Pic S96V99 means that this is an 8-digit number with the last two digits being on the other side of the decimal point. There's no decimal point because that would take up a byte, right? So an S means it's signed. So it's a signed number, which means that F is coming back from -1, and so yeah. So you got these different layouts, and then you have also the idea of we've got redefines. So see this redefines. This redefines basically means that this here is using the same space as this up here, and it's replacing that based upon a condition in the data. That's how you get that green bit in the earlier record set. And this one also says this is an array, so you've got to cater for the fact that this is an array of 6. This is 60 bytes, and then this one here is 6 bytes, and then there's 6 times 9, 54 bytes to make up the 60 bytes in that file. So that's how that works. And then reading that, which was done using a lot of regex. I did find somebody had written a PyPy library for this. It wasn't complete. It was a good first effort, and it had lots of bugs in it, but it was enough for me to pick up and then modify to complete the work. So here, this is a Django-based model that was generated programmatically by reading those copybooks and spitting out this, which enabled me to then use Django to write a migration script to generate the database table. And of course, for those of you who know Django's ORM layer, it's got a migration script built into it, which enables you to chain delta metadata changes, and then you can also go back as well. And this is my first iteration. I'll show you the second iteration later, but this is code. This is one of the subclasses processing the actual data. And this is reading from a database table that was storing the metadata, and it would write this code. So this is code written at build time. And there's about 1,000, just under 1,900 or so subclasses of a data processing class. And then each of them had a process data, and so it's polymorphism at work. And basically, it's saying, the line read the string and process those bytes based upon where that copybook is telling you to process those bytes. So that then evolved into something that looked more like this. And here we've got an integer. Here we've got a date. Now the date, the way we handled the date thing is there was effectively an abstract factory that had multiple subclasses of a date class, and you passed in the format of the date to the class factory, and it would then instantiate a class, a date management class that would then process the data accordingly. And here we've got a decimal. So just different snippets of different. Here's a string. So all of these are effectively. Okay. So some boring details. Basically, the data, if the data was a string field, then it would be, that would be fill. This here would spell out fill. But if this was a certain type of number, it would be reversed. And then that would generate a number like that. And yeah, I've mentioned about assigning. So I mentioned here, this is the overpunch example, and for those who are interested in this sort of stuff, they've used left and right curly braces because of EBCDIC as opposed to ASCII processing. And if the location of these, in terms of the EBCDIC table, makes this a natural choice in using, even though all of this is ASCII based, it's a leftover from the EBCDIC days. And then my final slide, why do they use Django? Few reasons. One, as already implied, the database updates were very, very easy to handle because of the migration script and the metadata management that Django provided. And also, because I wanted to keep everything fairly simple in terms of the general topology, I had three or four queues which were all managed from the database. The first queue was the decompression queue, which was created by the watchdog on entry. But then what happened is, as the processing class processed each of the decompression files, it would look inside that and go to each of the files that was in that decompression, in that zip file. And for each file in the zip file, it would create an entry in another queue that would then be processed once all 50 computers, not once all 50 computers had completed, but once there were no more files of that queue left to process. So every single computer would go looking in the decompression queue. Once they had all finished, then while machines were still processing, the next machine that was free would go to the next set of queues and get the next type of task, which was the differentiation task. And then once those were finished, it would then put an entry in the next queue. But this .select for update skip locked equals true is a Django facility that is associated with the Postgres dialect that enables you to effectively grab a record, but if it's already locked, don't wait, grab a next record. And that way you could basically process the queues knowing that you've got a guarantee thing. So just using regular tables for queue management just kept things really nice and simple. And that's all I've got. So any questions? Yes?
Did you run into any problems with time zones in the data?
Interesting question. No, because it was all Australian data. There were multi-time zones, but it didn't impact at all because everything was date-based, not date-time based. Yes?
You mentioned having inconsistencies in the data, so how would you manage those inconsistencies? You just say, well, the latest data is what we're going to take and ignore the rest?
Yeah, so yes, last entry wins, effectively. When, at first, I was going back to people and saying, look, I've got these issues, and when it was clear that they didn't really care, I didn't worry about it anymore. I mean, it's because a lot of the data was quite old. Yeah, so it basically became less of an issue. It was somebody, yeah.
I love your presentation as well, especially when you with COBOL. We just have a question about the generator. So it's when you convert from COBOL to ORM, so does it have a relationship between tables?
Sorry, could you just repeat that?
You generate the code automatically, right?
Yep.
Thank you. So I just wonder, the code generator, does it generate the relationship between the tables as well?
Good question. So the relationships, yes, it did. And the way that was handled was in the, just trying to remember how I did this. In the COBOL data definitions, there were indicators of that this was an ID coming from another. There were no actual IDs per se. There were no primary keys at all.
Yeah.
But I was able to store in metadata tables information about table, field, and then foreign key and field, because some of them were concatenated as well. So there was many subtables, so effectively 4 tables. And then that information was used to drive the generation of the Django data. So I used the code generator to write the data to the metadata to control tables, and then I used that to write the classes. Lots of questions.
You said you found a good start on, like someone else had made a good start on this. Did you make any pull requests, and was there any reaction?
I didn't push my code back. I didn't have the confidence to push it back, to be honest. But yeah, so here, and then here, and then here.
Okay. Okay, I understand that you use Django because it's easy to migration, but I also wondering, do you use PostgreSQL because this is the default option for Django?
Yeah, good question. There were 2 reasons why I chose PostgreSQL for this. The first reason was Django had the best support for Postgres. Although that was really a secondary reason, because the first reason was because if you take SQL Server stores everything in a clustered way. So using clustered indexes, which means physically you're shuffling data around and so forth when you're adding it. Now I could have written bulk update facilities and things, but because Postgres doesn't have that, it just writes data in. I found that data ingestion was a lot faster. And the reason I used 50 computers, virtual machines, is because each one of those 50 computers was thrashing the living crap out of the database, and 50 was the limit when everything started to fall over. Anything more, and the hard drive, the database couldn't handle it. But so that's why I chose Postgres. In the end, after this all finished, and the thing ran for about 4.5, 5 years, but there were 3 years where there was no human hands touching it. I'm very proud of that. And the only thing that didn't need to be changed was there were 4 tables that almost at the same time ran into the 32-bit integer limit. And I had to go back and change them to big ints. Now, I think you were next, sir, and then here, yeah.
So, the other thing was like, we have like 5,000 files all stored in zip archives. Definitely going to have data encryption. I have data encryption in tens of files. So how much of that data do you find was corrupted?
So the files themselves were not corrupted. The files were fine, healthy, but it was just sort of like where the program had written poorly, and it was like, for example, they'd written a byte offset or something like that, and so you end up with garbage characters and things like that, which generally was okay. There were a few things where they had to go back and bug fix so the next day. So we did it. I can't remember how I handled that sort of error handling, whether it was in the early days I just basically worked with their business analysts and said fix this. I know there was a lot of that initially, but then later on, I'm not sure how much self-healing there was in there, but I do know that they did see some things in the database and went, hang on, and then they would go back and tell it to reprocess. There was also a facility to say, wipe this file and reprocess it from first principles again too. So, sorry, there was a question over here.
First comment, actually following up from the Terraform issue, is that it was a similar infrastructure as code that caused the whole Beauty Super infrastructure to come down on Google Cloud earlier in the year. I don't know if people followed that one.
Yeah, very much
There was
so.
a misconfiguration at the start of the setup, and at the 1 year mark, basically it auto shut down everything. Luckily we had it back up with another cloud provider.
Yes.
But my actual question was, was there revision control in place for the original COBOL code base? And if so, did that give you insights into some of the reasoning that some of the original programmers used? And did you get perhaps a feel for the different styles that the different programs you worked on originally?
Was there revision control? Not really. In all honesty, it had been developing over such a long period of time, and it kind of got out of hand for them. And of course, they started it before there was any real version control systems and things, so it wasn't in good shape. It's now dead, so I think I can say that with safety. You know what I mean? It's no longer. But there was a point where I wouldn't be too willing to comment on that. You know what I mean? But in terms of the second part of your question about I didn't have too much close exposure to the COBOL code. I was mainly working through a business analyst interface and obviously talking to the developers as well, but I didn't have to delve into their COBOL code, and if I had, I probably wouldn't have understood most of it anyway. I did COBOL as part of my university training, which shows you how old I am, but which was really helpful, you know, decades on, to read these data dictionaries and things. Yeah, it gave me kind of a head start, but yeah.
So sorry to keep asking questions, but regarding a company that uses COBOL, do they still use tape backups too?
I don't know. That's the answer. Probably.
There's a lot of tape out there. There's a huge amount of tape. It's one of the longest term storage mechanisms there is.
Yeah, that's why I asked.
I actually had a fascinating dinner with the head of infrastructure for the Large Hadron Collider in the CERN facility. Oh my God, was that the most mind-blowing night of my life. But they had to use tape for the data they're storing, and every 4 years, I think it was, or 3 years, they had to transfer all the tapes to a new technology. And it would take 2 to 2.5 years to transfer the data from one tape system to another. Crazy. I'll go on in the back and then.
Yeah. Just a question about the use of the Django. Just a question about the use of the Django on your project here. So like you migrate data from COBOL to database, to new database, right? And then you're gonna be use Django to develop a new application on top of that one, or just use the Django for just migrate data?
Yeah, so we only use Django for the migration purposes. In fact, I'm not sure if I've already said this or not. I've got a bad headache tonight, but once the thing had finished completely and they turned the whole thing off, they then migrated it all to SQL Server because they were much more familiar with SQL Server, and that was the tool of choice inside. So it kind of all got migrated, and now they've got, because that was the other thing I mentioned very briefly, the 7-year issue. They literally had to get this across because even if they turned it off, they've got to be able to recover that data for 7 years, and they need a COBOL team to be able to access the data. So having it in SQL Server was important for them.
Okay. Thank you.
Can you say something about my process? I've done a few of these migrations myself.
Yeah.
I find you kind of live conceptually with it more in your head. So did you come to this, how did you
kind of arrive at the solution? Were certain things you had to prove, or were there things that you knew would work and other things that are doubtful and you had maybe multiple goes at solving? Because there's usually really hard bits and really easy bits.
Yeah, good question. So the first thing I had to do was develop some kind of proof of concept. I was presented with a wall of hex, and I chose, I think, the debtor's master file, because it sort of felt to me like it's likely to be something I could read. And then when I started to see the word street or something appearing in the hex, I'm going, oh geez, beauty. So I'm able to, and initially I used Excel to just convert the hex into something, so okay, yeah, I'm getting a feel for how these are written, right? And then there's obviously the complications that I mentioned. Those complications came a fair bit later, but the first instance was just picking a file and saying, can I process this end to end? The watchdog and the thing was all for later, but the first instance was simply, can I write a file? Now, I personally spent about 25 grand on a computer. That's not counting monitors or anything, it's just the computer, which was 128 gig of RAM and at the time 32 processors. I think it's a few years ago now. It was an expensive machine, so that I could run VMware workstations on it. With VMware machine, I ran 14 machines simultaneously as I'm scaling this thing up, just to see how it's feeling. But then what was interesting, the side thing with this was I mentioned a video with showing a Windows thing, and I had the C-suite was in this meeting, and they were all kind of very, very excited by what they saw in terms of the possibilities. That went viral, and then I had a lot of problems with people coming to me thinking that what I was doing was building that user interface. So they thought I was writing an application for them. They knew ERP front end, right? Which was not the case. So I had to spend a lot of time saying, hey, what I'm building you can't see. There's no interface for it, right? But then the other aspect of that, which became annoying through it, was I had 5 or 6 different teams that all wanted me to track the project through their methodology. And eventually I just said, look, I'm spending more time doing red tape than I am doing code. Choose one and I'll do that. The other aspect of that initial thing is I was thinking at the beginning, do I hire a team of 15 to do this work, or do I do it myself? And that was another thought process I had to go through. And I thought, at the end of the day, I can probably do it in about the same amount of time myself as if I hired a team of 15 and used them to do it. And I reckon I was pretty right. It took me close to a year to write the whole thing. The other aspect was, there was a lot of it in my head conceptually. And so I was enjoying it, but I was doing 100 hours a week or more because I didn't want to stop, because I wanted to be able to keep juggling it in my head, right? Keep the balls in the air. And so I pushed hard, but it was a good year. I enjoyed it.
How did you know that it would scale up? I mean, might have got to 10 or something servers and hit locking on the database.
Yeah.
And therefore it could have taken years, not 6 days.
That's right. Yeah. So on that front, it was experimental, and I tried 10 computers, I tried 20, I tried 40, I tried 80. 80 crashed and burned. So then I came back, and then I just kept incrementing until I got to a number that was the maximum. But at that point, the data's processing through to about 2 a.m., 3 a.m. And then I wanted it to be available for use by 9 a.m. And it was about 4.5 hours of processing time with the 50 computers. And that was fun. I could have actually, if I needed to speed it up further, I could have put 200 computers on that first decompression part and then the differentiation part, because they were not data bound. But that just added complexity that I just didn't need, because I didn't need to make it any faster.
All right, so thank you so much, Alan, for the talk. I hope you guys are having a All right, so if you have any more questions, feel free to reach out to him on LinkedIn, or we'll be having him on the Slack channel as well. And let's enjoy the break, 15-minute break, and we'll start back at 7. Tell us more about the conference and how you can get involved.
Hi everyone. That's better. Hi, I'm Peter. Everyone's come out here tonight and gone, wow, like 2 talks about Python, this is great. I really love going out to see 2 talks about Python. But is anyone feeling like, I wish it was 60 talks about Python or 70 talks about Python? Because PyCon AU is coming up in November. It was in Adelaide last year, it's in Melbourne this year. Here's the show from Adelaide, isn't it great? You should get a ticket. You should come along. Tickets are currently on sale. We've already lined up speakers, we've lined up volunteers, and now all we need is for everyone in this room, plus about 500 other people, to all show up and have a great time. So I hope to see you all there in November.
Thanks, Peter. Hope everybody's excited about PyCon. And let's get started with the talk by Mohammad. 1 second, I'll just quickly introduce him and we can get started with the talk. So Mohammad is a lecturer at Swinburne University, and he'll be talking on knowledge graphs and GNNs. So yeah, he'll tell us more about what GNN is, because I'm not really aware of that. So yeah, let's get started.
Hi everyone. I'm Mohammad, a lecturer at Swinburne University, Deakin, as well as Melbourne University, 3 units. So I teach at 3 units at the moment. Mainly I teach machine learning, deep learning, introduction to AI and insights in business, so all AI related units. So in today's speak, I was preparing 2 slides, to be honest. So the first slide, I'm gonna show something with So let's go through it. It was like graph neural networks. So for graph neural networks, we have several types. The idea of graph neural networks come from the CNN, convolutional neural network. So for me, like I was thinking yesterday, what should I speak tomorrow? Like, what I'm gonna go to say. So when I say it, like then I just went through this, and then I start to find lots of equations. I said, no, people will never like it. No one will like it. So that's why then I changed my mind, and I went to something more advanced, more like hot topic at the moment, which is knowledge graphs and generative AI. So before I start, I would like to ask, anyone know what's the meaning of knowledge graphs? Yeah, go on.
I don't have a good definition, but yeah, I've read that one.
Knowledge graphs. Yeah, so anyone want to tell me? Yeah, anyone want to tell me? Yeah.
It's just in my experience, in my view, that knowledge graph it would be something like your knowledge in different fields, but linked together somehow in some project. You showcase how your ability.
Yeah, that's a good answer. So I'm gonna give you like a quick example about knowledge graphs. So knowledge graphs is similar to any graphs in the world. It has nodes, links, entities, edges, all these things. So let's start by the basic concept of knowledge graphs. So if I tell you like every object in this slide, every person, it's a part of knowledge graphs. So I am like a part of knowledge graph. My name is Mohammad, and there's another node there. Like I'm the first node, and there's another node there, like it's sleep, because I'm a bit sleepy. I'm working since 10 a.m. today. I have 4 classes. So there is another node sleep. So when I have this, like I'm Mohammed, and there is another node sleep. What's the relationship between me and sleep?
You want to sleep.
Yeah, so it's a need. Exactly. And there I can see that there's a coffee. Okay, so in that coffee, that's another node. So what's the relationship between me, coffee, and sleep?
Stay awake.
Which means prevent. So like coffee prevents sleep. So this is like how we can understand the knowledge graph. So we have everything in this life is a node, and there's a link, and the link on the edge it's based on what we have together. So this is like for So this is like the relationship between nodes. Let's talk another. I'm gonna give you another example. Then I will start in the main topic. So let's say now you want recipe. Like I'm starving, so I want a recipe for pizza. So pizza is node. So anyone can tell me what other nodes are linked with pizza? Oven. Okay. We can say capsicum. We can say cheese. And all the ingredients. Yeah, all the ingredients are nodes. So are nodes, and there is a link between them. So let's say I want a specific type of pizza. I want Indian pizza. So it will contain curry, right? So definitely when I go for when we see Indian pizza, we will see like the Indian pizza is connected with curry, or maybe connected with something called, I'm not from India, but it's something called kasuri methi. So something like Indian use it for cooking. So I love cooking, so that's why I'm talking about this example. So this is like the main idea of knowledge graphs. We have nodes, we have relationship between them. So this is the most important part of knowledge graphs. How we can use knowledge graphs and LLMs, large language models. Normally once we listen like large language model, yeah, this is the top. So everyone is interested, right? So for the large language models. So large language models, like it's generative AI, like we use it everywhere. Before, like I guess like 2 years ago, when we use ChatGPT or Gemini, Llama, or whatever we use, so they used to give us some wrong answers. Even now, like let's say if I send a prompt for ChatGPT, 1 + 1 equal 2. So but if I tell ChatGPT, no, this is wrong, they will say, sorry, like yeah, you are correct. So this is like, and this is really common in generative AI. Meanwhile, like as we know as well, like training ChatGPT or Gemini models will like takes lots of time, right? So every day we have updates. Every day we have a new information. Every day we have a new data. So what do you think like retraining, do you think retraining LLMs every day will be efficient or will be good? Or we can do it? It's doable? No, definitely not, because like the ChatGPT, the first time take 1 year and 3 months to be trained. So it takes like roughly like 1 year and 3 months to train, because it has like more than 17 billion parameters. So once they fine tune it, they build it, it takes lots of time. So that's why I'm going to talk now about knowledge graphs and why they are important, and how we can use knowledge graphs to avoid retrain the model. And we just use data store, like we can store graphs, store information, and we can use them every day to get the more accurate and the best answers, responses from LLMs. So what we will cover today, like we will cover knowledge graphs, graph data science, and semantic search. So as we know, like LLMs give us lots of amazing opportunities, right? So let's automated data retrieval tasks. So this is one of the most important tasks. Improve customer service experience. So now lots of companies they don't want like agents for customer service, like call centers and all these things. So they try to replace it by LLMs, because they do the same thing, because they have the procedure, they follow it, and they try, even they are more patient to handle angry customers. So they say yes, and then they keep going. So and then we have like summarizing, getting to that reading and understanding, and then we have generate content and code. So this is one of the best parts for LLMs. So these days, like if you want to manually annotate data, anyone has tried to annotate data before? And manual labeling, like annotate, like means like we label the data. Anyone? Okay. How long did it take from you to annotate maybe 1,000 records? Week? Yeah. Have you tried Amazon Talk? No. So because they are not accurate, they just press yes. It's not like they just try to write and that's it. So this is like Amazon Talk, like it's one of the tools we use like for labeling. It works like if you have image data, but if you have textual data, it won't work. Like I have really bad experience with that as well. So I manually labeled 100,000 tweets, not by myself, definitely. So I manually labeled them to estimate severity of eating disorders. So because we are building a model to detect eating disorders based on online behavior, so we need to use some tweets and some profile information to train our models. So we spent 6 months, me and 12 psychologists, 12 months of 4 to 5 hours daily labeling. So imagine you have 100,000 tweets, it's a massive number. Well, after we finish it, we trained the model and we achieved 94 accuracy, which is perfect. So now we can estimate the accuracy of eating disorders easily by our models. So LLMs helps us like in manually labeling. So instead of you do manual labeling, so now what we do, we can just label data. Once we finish, we can take some sample and we do human validation, and that's it. So this is like one of the best usage of LLM these days. So let's go to the next. This is like a previous example of how we used to talk with LLMs. So what was the impact of Hurricane Lee? So before, like it was Hurricane Lee was a long-lasting tropical cyclone that formed in the Atlantic during 2017 hurricane season. So this is the general answer, right? So anyone can know it, right? Like even ChatGPT, even me, even any person in the life, like if they know what's the meaning of Hurricane Lee, they will answer the same question. But with knowledge graphs, what we can find more information, like how we can enrich the response, and we can make response more accurate and provide more information for the user, like when I ask about something. So if we ask about Hurricane Lee, let's say this is a node, okay? So anyone can give me some examples like what kind of nodes, like knowledge graphs nodes or entities are linked with hurricane links. So we can talk about, yeah, disaster, no electricity, no calls, no internet,
Location.
so we are disconnected from everywhere. So such that at the beginning, ChatGPT, or like when I say ChatGPT, just consider it LLM because it's like Uber. Like now, like if you want to pick an Uber, yeah, I want to pick an Uber. Like but there is other companies, but like Uber take the reputation. So that's why I talk about LLMs as ChatGPT. So for Hurricane Lee, so this is like the basic answer. But if I want to enrich the answer, I need more knowledge and I need more data. Oh, maybe this is a human mistake. This is a human mistake. So there are some challenges like in LLMs. Like we have knowledge cutoff, reasonable answers, not always accurate. It can be based on training data, like enterprise domain knowledge, which is one of the most important parts from my side, and ability to verify or attribute sources. If you now do some research, if you want to do some research, and when I do marking for my students, every single semester I see the same thing. Students, they ask me, like, yeah, have you used AI to solve your report? They say, no, we haven't used it. And I see all the excuses. At the beginning, like when I go to references, I take reference, I just copy it and paste it at Google Scholar. The reference is not there. so it's generated from AI. Because they don't have like AI, like they just generate random references. It's not accurate. They are not correct. Even they are not found. Sometimes like I use it when I was doing my PhD. I used to please find me a paper like related to deep learning and in this part. So I checked by myself. Like I didn't find any paper. ChatGPT gave me 12 papers or 14 papers. And I felt like I have the hope, yes, I found the papers. I want to have some references to like evidence for my work when I go and check in Google Scholar. And the thing actually, I don't check only on Google Scholar. Back then, I checked Google Scholar, like Scholars. I checked DeepL everywhere. At the end, nothing. I didn't find anything. So this is like the most challenges. So how can we take advantage of this massive opportunity while overcoming these challenges? So the most important part, like in today's talk, like use the knowledge graph to ground LLMs. So grounding is important everywhere, even for a human. Like we need to be grounded to be more productive, to be more responsible, and we can do many things. So what was the impact of Hurricane? Then this is like how LLMs works. So this is the prompt, like user asks a question. Here we have LLM smart search. Before, like they don't use the query and relevant info in Neo4j. So this part was missed before. So it was only ask question, LLM smart search, LLM question and relevant info, and then we have the answer. But nowadays, what we do, like we have the user ask a question, then we have smart search. We have a query here, like it's cipher query. So we talk with Neo4j. Neo4j it's like where we store graph data. So this is like where we store graph data. So Neo4j knowledge graphs, and then we provide our cipher. Then we retrieve like the top 5 or top 10. It's based on our parameter, how we can fine tune our model to make sure like we get the best results. Then it retrieves the relevant information as a graph. So we have something called the graph RAG or RAG, like retrieval augmented retrieval augmented generation. Yeah, sorry. So and then like this kind of things, like it's transfer, like change the ciphers into the English text, and then it enrich the prompt, and then we can have like the most important information. So then like we have the LLM question, the user prompt, as well as the relevant information, and then we get enriched answers. So this is like, so if we can see like currently may impact disruption networks, the following areas, MA, like New York, I don't know what's these stands for in states. So this is like, so after that, we have a grounding with Neo4j knowledge graph. So we have a connect rich, connected view of your data that enables easier decision making. And then we need to enhance our data with graph data science, text embeddings, and additional derived context. And then we will have like a ground response improved search relevance combining vector search and graph tree. So after that, we have some connected data with knowledge graphs. So we have like structured and unstructured dataset data. We have the natural relationships, and then here we have semantics, and we have derived relationships and additional context. We have here some graph algorithms and graphic queries. We store all of them in Neo4j, and then we can talk with Neo4j for using graph rag or RAG, or also we can use some ciphers. So what can you do with knowledge graph? So I'm going to show you now like lots of things what we can do with knowledge graphs. So first thing actually we can use in finance. So how many flagged accounts are in the applicant's network? 4 plus hops. Like hops like mean how many steps. Like let's say this is the account holder. This is the first hop, second hop, third hop. So this is like what we mean by hop. So how many login account variables in common? So this is like how we use it in finance. We can use it in life science. So what completes the connection from GNNs to disease targets? What GNNs like can be reached? So this is like again like also we can use it on marketing and recommendation. So for marketing and recommendation, like nowadays actually, if you check how YouTube works, like when you search for video. Let's say I was looking for a rag before I came because I didn't prepare yesterday. No, I'm joking. So if I type like a graph rag or like rag or LLMs, so I will find like lots of relevant videos. So it works similar to the way knowledge graphs and Neo4j work. So how we can enrich like our LLM model, like the prompt. So we have like queries. So it's human crafted query, human readable results. So also we have algorithms, a predefined formula, human readable results, and the most important part, like normally, it's the embeddings, because all machine learning models, like we can enhance them by having more embeddings. Like we can use BERT embedding, you can use several embeddings. So this is like how we can train and how we can enrich. So what are graph algorithms? So graph algorithms, they are separated into 2 parts, whether like unsupervised and supervised. So anyone knows what the meaning of unsupervised? Yeah. Yeah. So So that means like we don't have any unlabeled data set. So this is like we call it unsupervised. Once we have unlabeled data set, directly we think about clustering. We have association or dimension reduction. So if I'm using unsupervised graph algorithms. So but for supervised machine learning, when I have labeled data set. So once I have labeled data set and I want to do some specific task, and because like I'm talking about graphs only, so we can link prediction. So I may predict let's say we have a new node, and I want to predict the link between me and the new node. So this is what we call link prediction. Node classification, sometimes like we have some nodes and I want to classify what's the type of this node. So one of my previous work, like I don't think like I have time today to share it, but one of my previous work like I've done, we worked on a project. So we considered each tweet as a node, and we linked. So like when I talk about nodes and tweets and all these things, all of them related to eating disorders. So we consider each tweet as a node, and the link between them, we used specific term. to eating disorders. One of the terms like EDTWT. Anyone know what that stands for? Eating disorder Twitter warning trigger. So people on Twitter, like experiencing eating disorders, they use these terms just to know themselves. It's like ID, like it's like or password. So they know it and they connect to each other, and they start promoting like diets, and they start to promote some like laxatives, some like how to vomit without your family notice, and so many things. So this is like, if anyone doesn't know what's the meaning of eating disorders is a mental health issue. Like there are subtypes of eating disorders like anorexia, bulimia, binge. So there are plenty of them. So, and that the worst thing actually, not everyone is familiar with this kind of like mental issues. By the way, it has the highest mortality rate, which is 60% all over the world, which is higher than depression, which is 8.7. So, so let's go back to supervised machine learning. So we did link prediction, model classification, and probability regression. So here, like I have some tools we can use. So, for example, for a graph embedding, we can use Not2Vec, FastVR, Graph Sage, and Hatch GNN. So there are like, and also for similarity, we can find node similarity, cosine similarity, and there are plenty of tools. So. So let's go to the next. So in Stoic, we have some insights from graph algorithms. So we have centrality, and pathfinding. We can find the shortest path, optimal path. Especially like here, if we sometimes like if we work with AI agents, again, so we can rely on shortest path and optimal path. So community detection, like as I mentioned on Twitter, so we can detect some eating disorder communities, and we try to intervene and have some early prevention. So which may help people. Similarity again, like for recommendation, what-if analysis, embeddings, dimensionality reduction, representation learning, and link prediction, recommendation, and next best action. So we have text embedding vector for semantic search. So giving a question most relevant, so we can find the similarity based on the semantic. So we can have like a top K by similarity. So abstract ID, let's say we have this abstract and this abstract, and we find similarity. So then we retrieve the top 5 or top 10 based on our model. So for graph science, graph data science journey, so it starts from knowledge graph, then we have graph algorithms, and the last thing is graph native ML, so which is like we will learn features that we don't know even about the graphs. So like last thing actually I'm gonna go through it, like consume with LLMs. So we can, in the beginning, like we start with vector similarity search, and then we start to use graph travels and pattern matching, and last thing actually we have knowledge. This is the most advanced one, so knowledge graphs and inference and machine learning. So this kind of things are really important. So we can discuss them later, maybe on the next one. So I'm just gonna show you a quick thing about RAG. So retrieve augmented generation. So like normally the user start like a prompt, like they write their question, and then we have LLM API, so embeddings and cipher generation, then cipher like how we build it, and it talks with Neo4j. But then after that, like we retrieve some relevant information, like then we take the prompt as well as the relevant, we concatenate them, we pass them to LLM API, and then we have our response, which will be enriched response and more accurate. So for this one, I prepared this one. Even the code is ready. If anyone wants the code, you can just text me, or you can just ask me now, so I can share it with you. I prepared the code, and even for LLM APIs, I tried several LLMs model. I tried GPT-2, I tried Llama, so I tried Gemini. So I'm just trying several models to find the best results. So this is like what I'm doing. So if anyone wants the code, I'm happy to share it with you. So and here like same thing, but this is like an example. Demo, I guess like it needs 1 hour to go through it, so we can't do it today. I was planning to do it, but maybe we can leave it for another meeting. I can write code in front of everyone, so I have the ability to write code without looking on the screen. So for next time, I'm gonna go like, if I have the chance to speak again, so I'm gonna go through the demo and I will write code in front of everyone, so and we can build full GPT model, like a generative AI model. So we can build it from scratch, which like this is like really important thing, and it's really nice, and it's really good to have an idea how we can build and how we can fine tune LLM. So for the demo and the LLM chatbots, I'm gonna go through maybe next time. And if anyone wants the code, like for Neo4j, if you want the code for tuning the GPT, Llama, Gemini, if you want even the ciphers, scrubbing knowledge graphs from Wikidata. So that, like now we have something called Wikidata. It has the biggest knowledge graph. So if you want to work with that, so I have the codes ready. So I finalized everything. I was prepared. I was planning to go through the code, but I said no. Let's go for like introduction.
Maybe for the code, like we can put up a Slack post and people can refer to the code from there. And if they have any questions, they can reach out to you.
Yeah, so I can publish it on GitHub.
That's perfect. Yes.
Yeah, so I will share it with the Digitech group, so they can maybe.
Yeah, we can post it on Slack.
Yeah. So that's the best way. Thank you.
All right. So let's. If you have any questions, let's like take a couple of them because we are running out of time. So if anybody has questions, raise your hand.
Thanks for that. Just a question on the embeddings. Without the graph, the embeddings are normally in a vector database. What's the advantage of putting the embeddings in the graph database with knowledge as well?
Like normally, it's a really good question by the way, because normally once we add the embeddings, the response will be much more accurate, and also the model normally could understand the embeddings more than the actual text. So that's why we prefer to have the embeddings. Yeah, and also like for embeddings again, like what normally I do, like I use Node to bake. So this kind of tools, like I use like this kind of libraries I use to generate the nodes, and I keep them each node embeddings, and I pass them while tuning the model. So in this way, like you can find the results, and even the tuning process will be a bit faster and easier.
Awesome.
My question again about tech embedding, because I feel like because tech embedding is type algorithm, right? And like I want to improve my output, so the thing I need is to put more quality data to the tech embedding, and then get the better output, or I can improve something in the tech embedding. So you can improve the embedding, like you can let's say.
So for the embeddings, like instead of using only graph embeddings, so we can generate text. We can generate embeddings for the user prompt, and then we can concatenate them as well with the model. We can generate like the knowledge, like graphs embeddings and node embeddings, and also we can generate like the whole graph embeddings. So and normally we take average, and also one of the best way normally to implement nodes, you can add some features, and after that you get the embeddings. So and also you can add the embeddings as a node features as well. So in this way you will enrich the model fully, and the graph it will be like even the nodes will be more clear and easy to understand by a human as well as by the algorithms.
All right, so that concludes the second talk. So thank you, Mohammad, for the talk. I hope everybody enjoyed the talk. And next item on the agenda is that we have marketplace now. So if anybody is hiring, maybe you wanna talk about it, about the role, and see who might be interested to talk about the role to join. If anybody's interested, Is anybody hiring here? Okay, probably not. So, if nobody's hiring, just I'm looking for jobs. So if anybody's interested, just let me know.
I definitely am. Otherwise, it won't be a
James, do you
business.
want to talk about?
I mean, any stack, anyone who's looking for a role, we can help out in some way, shape, or form. So yeah, if you look on the Just Digital People website, we've got all of our postings listed. There'll be loads of software engineering, data analytics, data science roles on there, marketing as well. So
Anything for security folks like me?
we might do, mate. I'll have to speak to the guys tomorrow. But yeah, we've got a team of 10 people. So even if we've got no specific roles for you, still get in touch because we can give you general advice, how to approach the market, even CV feedback. So yeah, we're happy to help if we can in any way.
All right, so awesome. That sounds good. I'll probably reach out to him. And if anybody is like student like me and want to reach out to him, feel free to text him on LinkedIn. And thank you so much for attending the talks. And we'll continue with the networking by I think 7:50 or so, and then we can wrap up the meetup. Thank you so much everybody for joining.